So whether or not it's a redox reaction, if you see oxygen, usually there's going to be a redox reaction. That's where we get the name oxidation from, or oxidizing. It's because oxygen is the one that usually does that the most, and so that's why if you see oxygen, that's something to kind of be like a red flag, like, oh, let me check, make sure that this is a redox reaction. And then just some mnemonics for this. There's oil rig. And do you remember what that stands for?
Basically, oxidation loses electrons,
Yep.
and reduction gains electrons.
Yep, exactly right. And so that's going to help us figure out whether or not there's going to be a redox reaction. And then we're going to want to look at oxidation states. Oxidation states are basically just describing the charges, but not really a charge. Does that make sense? I'm going to put parentheses around it because I can't think of a better way to describe it. It's not a charge, but you can think of it that way. Does that make sense?
Okay.
So it's numbers that we assign to the different atoms to kind of signify how many of the electrons are getting and stuff like that when it's in a molecule. Does that make sense?
I think so.
Okay, cool. So we'll, now that we did that quick review, let's throw one of those problems up here on the board and then we can go through it.
It's kind of ugly. You'll probably just want me to read it to you.
Okay, perfect.
NH3, which is aqueous. I don't know if you need to know that or not.
Aqueous. Yep.
Plus 2 O2s,
Uh-huh.
and it's gas. Goes to HNO3, aqueous, and water.
Cool. And that's liquid. All right. So basically what we're looking at here is if anybody's charges or oxidation, so charges change when we go through this.
It's looking specifically for the change between the nitrogens.
Okay, perfect. So they already told us that this is so they've already told us that these are redox reactions.
Okay.
So, but let's pretend that we didn't know that it was one, just so we can kind of walk through that for example, and by walking through it, we'll answer the question.
Okay.
Okay, so we'd want to look at the oxidation states of these guys, and we know that oxygen's is always going to be
A -2.
-2, exactly right. So this guy is -2, and right here, did he change at all?
Well, there's 2 on the left, and only 1 on the right. I don't know if that
So
means anything.
so that would influence the total if we're looking at it as a charge, but this doesn't have a charge to it because it's in its natural state.
Okay. So the only way that it would change is if it has some kind of a charge.
The only way that it would change is based on the partners that it's with, right?
Okay. So because the H's are always a +1,
Right.
and you have 2 of them,
Exactly right.
then it's still going to be a -2.
Exactly right. So because we have 2 of these guys, there are always a +1 oxidation state with a nonmetal, right? And so we know that oxygen didn't change. Okay, so nothing happened with oxygen right here. But if we look at this, so this guy's going to be a -2, but we have 3 of them, right? So that's going to be a total of -6, and we know that hydrogen
It's going to be a +1.
a +1, right? Which makes this nitrogen have to be what?
A +5.
+5. Exactly right.
Okay.
Okay, so if we look at this guy right here, if we know that this hydrogen is always a +1, right? And there's 3 of them, so this is +3.
Right.
Sorry.
You're good.
And that would make this nitrogen have to be what?
A +2. Or no. Wait.
If we want it to be 0.
It's going to be a -3.
Right. And so this number and this number
So it lost
are
electrons.
different. Right.
Okay. So that's a reduction.
So if oil rig, right?
Or, sorry. It's oxidizing.
Right.
That's always gonna mess me up. Okay. So the next one is even uglier. And my husband just called me, so I'm gonna send him a text.
Yeah, my wife's been calling me. Okay. So you're right. So this is going to be an oxidation because we lost electrons going from here to here.
Mm-hmm.
Exactly right.
Okay. So there's one here that doesn't have any oxygen. Does that mean that it's not a redox reaction? Because that is an option.
Right.
Okay.
It's not asking us whether or not it's a redox reaction. It's asking us whether or not that atom in particular was reduced or oxidized. Does that make sense?
Okay.
And so once again, we would just want to look at
So there's a difference between a redox reaction and something being oxidized and something being reduced.
So, no, that they're one and the same, but they're not asking us if it is a redox reaction.
Mm-hmm.
Does that make sense?
Right.
They're just asking us specifically about each of those compounds.
Okay.
Does that make sense? And so it could, like for the first one,
Mm-hmm.
We know that because it did change that there was an oxidation, that it was a redox reaction. Does that make sense?
Mm-hmm.
For this one, we're at here where we're not sure if there's no oxygen. It might not be a redox reaction,
Okay.
but we're just specifically asking if it was reduced or oxidized.
Okay.
Does that make sense?
Mm-hmm.
So, I mean, yeah. So there is always oxidation and reduction in every redox reaction. And if there is, then it is a redox reaction. So they're connected. So if it's a redox reaction, then something got reduced and something got oxidized.
Mm-hmm.
If it didn't, if nothing got reduced or nothing got oxidized, then it's not a redox reaction.
Okay.
But they're just asking us specifically about those things. So something else in that equation could have been oxidized or reduced, but they're just asking specifically about that one item. Does that make sense?
Mm-hmm.
Okay, cool.